Okay, so this is the last part of the Unit 8 review for the statistics unit. So for question number 26, tells you that the average score for the Math 3 final exam was 70% with a standard deviation of 11. So you know the average score was 70 and the standard deviation was 11. Assuming that the scores were normally distributed, and use the empirical rule to answer the following questions. So since we're talking about a normal distribution, so whenever we see that word or the empirical rule, that means we want to set up our normal curve. So I'm just going to sketch one out. And I know in the middle is my average, and then I go plus 1 standard deviation away. And so the scores go at the bottom here, so I want to put in my average, and then to find the rest of them I want to just add 11 each time. So I know that my standard deviation was 11, so I'm going to do 70 plus 11, and then add 11 again, and I want to do the same going the other way. So I'm going to do 70 minus 11, and then 59 minus 11. And then my percentage, so these are 34, and then 13.5, and then 2.5. Okay, so there's kind of my normal distribution. So it's asking what percent of the students scored above a 92%. So a 92 score, and then above it meaning going this way, so that means 2.5% of the students scored above a 92. Okay, and then for part B, what percent of students score between a 59 and an 81? So between a 59 and an 81 is 34 and 34, so that would be 68%. And so then for part C, it says if 1,200 students district-wide took the final exam, how many scored between 81 and 92? So if I look down here, between 81 and 92 was 13.5%. So 13.5% of the 1,200. So I want to multiply the percentage of students times the number of students. So I'm going to make that into a decimal. So I would do 0.135 times 1,200. Which is 162. So 162 students, which is 13.5% of them, scored between an 81 and a 92. And then for the last one, it says if 1,200 students took the final, how many scored below a 59? So below a 59%, so here's the 59%. So this is 13.5 and 2.5, so that would be 16% of the students. I'm just adding 13.5 and 2.5 of the 1,200. So make that into a decimal, so 0.16 times 1,200, which is 192. So 192 students scored below a 59%. Okay. All right, for question number 27, it says a sample size of 300 from a normal population has a mean of 265. So that means there's 300, and my mean is 265, and a standard deviation of 40. Using the empirical rule, so a normal distribution, how many items of the sample will be above 305, and how many will be below 225? So again, I want to go ahead and set up my curve. So 265 was my average, and then my standard deviation was 40, so I'm going to add 40 to the right. And I'm going to do one more. And then I'm going to subtract 40. So oops. And then fill in my percentages. So 34, 13.5. Okay, so let's see, what do we want to do again? So how many are above 305? So above 305 is here. So that would be 13.5 plus 2.5. So that would be 16%. So then I want to do 16%. So for the above, I'm going to do 16% times 300, and so that will really be 0.16, right? So 0.16 times 300 is 48. So 48 of the people scored above a 305. So then for below 225 is right here, and so also 16%, right? So 16% of the people scored below 225 and 16% scored above 305. And so that would be the same number, so 48. Okay. All right, for question number 28, so the average score on a company's exam was 45 with a standard deviation of 7. So the average was 45 and the standard deviation was 7. And they want to know what percent will score more than 31 to 59 on the exam. So what percent will score more than 31 to 59? And then we're assuming to be normal. So we're just going to do another curve here. Just do that here. So my average is in the middle, and then I'm going to add 7. And one more time. And subtract 7. And one more time. So this is 34, 13.5. So I want to figure out the percentage in between 31 and 59, so I'm just going to add up all of these numbers. So 34 and 34 is my 68, and then 13.5 and 13.5 is 27, so that would be 95%. So 95% score between a 31 and 59. Okay. Okay, get another piece of paper here. So for question number 29, says last year Mrs. Matthews' PG&E bill averaged $200 for the first 3 months. So her average was $200 for 3 months. And then averaged $300 for 7 months, and then averaged $150 for 2 months. And so they want to know what was the total amount paid to PG&E for the year. So if it's an average of $200 for 3 months, that means it was $200 for, say, January, February, and March. So then I would just do 200 times 3. So it's $600 altogether for the first 3. This is $300 then for the next 7 months, so on average, right? So $300 for each month for 7 months. So I just want to do 300 times 7, or 2,100. And then for the last 2 months, it was $150. So each month it was $150, and it was for 2 months. So multiply, so that gives me 300. So to find the total amount, then I would just add up those numbers there. So I would do 600 plus 2100 plus 300. And so that would be $3,000 for the whole year. Okay, so that's the first part. So the total amount paid was $3,000 for the year. And then here, now they want you to find the average monthly bill for the whole year. So this is the average for just 3 months, the average for 7, the average for 2. So now I want to know the average for all 12 months. So I know that it was $3,000 for the year. So the average for each month then would be 3,000 divided by 12, because there's 12 months in the year. And so the average per month was $250, okay? So on average, she did $250, okay? All right, and then the last side here. Okay, so for question number 30, it says that the weight of chocolate bars from a particular chocolate factory has a mean of 8 ounces with a standard deviation of 0.1. And you want to know what is a z-score corresponding to a weight of 8.17. So the z-score formula is your actual value, right, minus your mean divided by your standard deviation. And you don't have to have the formula memorized, it'll be given to you. So the value of the weight was 8.17 minus, and this is just another symbol for average, right? So minus 8 divided by your standard deviation, which is 0.1. So you're going to do 8.17 minus 8, and then divided by 0.1. And so your z-score would be plus 1.7.